Today, we will talk about the Autoregressive Integrated Moving Average, ARIMA, prediction model. An autoregressive integrated moving average, or ARIMA, is a statistical analysis model that uses time series data to either better understand the data set or to predict future trends. An autoregressive integrated moving average model is a form of regression analysis that gauges the strength of one dependent variable relative to other changing variables. The model's goal is to predict future securities or financial market moves by examining the differences between values in the series instead of through actual values. Each component in ARIMA functions as a parameter with a standard notation. For ARIMA models, a standard notation would be ARIMA with P, D, and Q, where integer values substitute for the parameters to indicate the type of ARIMA model used. The parameters can be defined as P is the order of the autoregressive part, D is the degree of differencing, and Q is the order of the moving average part. For example, a linear regression model includes the number and type of terms. In an autoregressive integrated moving average model, the data are differenced in order to make it stationary. A model that shows stationarity is one that shows there is constancy to the data over time. Most economic and market data show trends, so the purpose of differencing is to remove any trends or seasonal structures. To begin building an ARIMA model for an investment, you download as much of the price data as you can. Once you've identified the trends for the data, you identify the lowest order of differencing by observing the autocorrelations. Next, determine the order of regression, P, and order of moving average, Q, by comparing autocorrelations and partial autocorrelations. Once you have the information you need, you can choose the model you'll use. ARIMA models have strong points and are good at forecasting based on past circumstances, but there are more reasons to be cautious when using ARIMA. ARIMA models assume that past values have some residual effect on current or future values and use data from the past to forecast future events. ARIMA is a method for forecasting or predicting future outcomes based on a historical time series. It is based on the statistical concept of serial correlation, where past data points influence future data points. ARIMA combines autoregressive features with those of moving averages. An AR autoregressive process is one in which the current value is based on the immediately preceding value, while an AR process is one in which the current value is based on the previous two values. A moving average is a calculation used to analyze data points by creating a series of averages of different subsets of the full data set to smooth out the influence of outliers. ARIMA forecasting is achieved by plugging in time series data for the variable of interest. Statistical software will identify the appropriate number of lags or amount of differencing to be applied to the data and check for stationarity. It will then output the results, which are often interpreted similarly to that of a multiple linear regression model. The ARIMA model is used as a forecasting tool to predict how something will act in the future based on past performance. It is used in technical analysis to predict an asset's future performance. ARIMA modeling is generally inadequate for long-term forecastings, such as more than 6 months ahead, because it uses past data and parameters that are influenced by human thinking. For this reason, it is best used with other technical analysis tools to get a clearer picture of an asset's performance. Here are 5 key takeaways. 1. Autoregressive integrated moving average, ARIMA, models predict future values based on past values. 2. ARIMA makes use of lagged moving averages to smooth time series data. 3. They are widely used in technical analysis to forecast future security prices. 4. Autoregressive models implicitly assume that the future will resemble the past. 5. Therefore, they can prove inaccurate under certain market conditions, such as financial crises or periods of rapid technological change. Hope this would help. Thanks for watching.